Hello, my little mathematicians. All right, so today we're going to explore word problems involving GCF, or greatest common factors. So if we take a look at the first one, it says Sarah has 16 red flowers and 24 yellow flowers. She wants to make bouquets with the same number of each color flower in each bouquet. What is the greatest number of bouquets that she can make? So the trick with these ones is what they're looking to do is they want each table to have the same exact amount of groups. So they want the same amount of red and the same amount of yellow at every single table. Nobody has any more or less. And they don't want any to not get used. So you're trying to find the greatest common factor. And for these word problems, you'll notice right here the greatest number of whatever it is they're talking about of groups that they can make. And the two numbers I'm dealing with are 16 and 24. The way that you're going to see me solving for it is what we call the ladder upside down cake method. It's just the easiest. Okay, so think of any number that can go into both 16 and 24. Can you think of one? The one that comes to mind for me is 4. So 4 times what is 16? 4. 4 times what is 24? 6. Okay, am I done? Or is there anything else that can go into 4 and 6? Well, I see that 2 can go into both 4 and 6. 2 goes into 4 2 times, and 2 goes into 6 3 times. Can I keep going? Can anything go into 2 and 3? I'm done. So since I'm asked to find the GCF, I just multiply these numbers along the side right here. 4 times 2 is 8, which means the greatest number of bouquets that I can have is 8 bouquets. Now, for some reason, your ladder looks a little bit different than mine. Let's say you started with 2. It's still okay. As long as you don't make a math error, you should still end with the same answer, because 2 goes into 16, 8. 2 goes into 24 12 times. And then what can go into 8 and 12? Some people would say 2. I'm going to say 4 because I don't have that much space left. 4 goes into 8 2 times. 4 goes into 12 3 times. You're still left with 2 and 3 on the bottom, and 2 times 4 is 8. And even if you did a 2 here, you would have just had one more row. And when you multiplied those numbers, you still would have gotten 8. All right, so let's go ahead and take a look at our next one. It says Kira baked 30 oatmeal cookies and 48 chocolate chip cookies to package in plastic containers for her friends at school. She wants to divide the cookies into identical containers so that each container has the same number of each kind of cookie. If she wants each container to have the greatest number of cookies possible, how many plastic containers does she need? Okay, so again, this is a GCF problem, right? You're trying to find the greatest number of cookies possible that you can make with each one having the same kind, or the same amount of each kind. So I'm dealing with the numbers of 30 and 48. 30 oatmeal and 48 chocolate chip. Okay, so what can go into both of those numbers? 2 can. Can you think of anything bigger? I see 6 that can go in. 6 times what is 30? 5. 6 times what is 48? 8. Can I keep going? Can anything go into 5 and 8? No, so I'm done. Now, even if you had started, let's say with 2, you would have had 2 goes into 30 15 times, 2 goes into 48 24 times, and then 3 can go into both of those 5 and 8 times. You still end with 2 times 3 is 6 containers. And the really cool thing about how setting it up like this is this tells me how many groups there are, and this is how many of each kind are in each group. So I have 6 containers, each containing 5 of the, 30 was oatmeal, so 5 oatmeal cookies, and 8, 48 was talking about chocolate chip cookies. So 6 containers, each containing 5 oatmeal cookies and 8 chocolate chip cookies. And that's why I like setting it up like this. Not only does it give me the GCF, but also it kind of tells me like what it means and what's in each container. Okay, if you haven't already paused the video and tried some of them yourself, I suggest why don't you pause it, try this one, and then come back and check. All right, now that you unpaused it and you're back with me, let's go ahead and try it together. It says Dan has 24 blue pens and 72 red pens. He wants to put them in packages with the same number of blue and red pens in each package. What is the greatest number of packages he can make? So you have 24 blue and 72 red. Okay, what can go into both 24 and 72? Well, it's even, so you know 2 can. Can you think of anything bigger? I see this 72, and I know 8 times 9. 8 can also go into 24, so let's pull out an 8. 8 times what is 24? 3. And 8 times what is 72? We said 9. Can I keep going? Yeah, what can go into both 3 and 9? 3 can. 3 times what is 3? 1. And 3 times what is 9? 3. Can anything go into both 1 and 3? Nope. So let's multiply those numbers along the side. You have 8 times 3 is 24. So you have 24 packages of pens. And if you were curious, there's in each package, there would be 1 blue pen and 3 red pens. Okay. Our next one says, Peter has 18 oranges, 27 pears, and 12 bananas. He wants to make fruit baskets with the same number of each fruit in each basket. What is the greatest number of fruit baskets he can make? How many of each type of fruit will be in the basket? Ooh, this one's a little bit trickier, huh? Okay, so this time we actually have 3 numbers. We have 18, 27, and 12. And if we're doing GCF, we can actually do all 3 at the same time. When we do LCM later, we have to do them 2 at a time, but GCF is nice. We can do all 3. So what number can go into those 3 numbers? 3 can. 3 goes into 18 how many times? 6 times. And 3 goes into 27 how many times? 9 times. And 3 goes into 12 how many times? 4 times. Now, can anything go into 6, 9, and 4? No. Like, yes, 3 can go into both of those, but 3 can't go into 4, so I can't keep going. So the greatest number of baskets that I can have is 3 baskets, and this particular problem asked me about the specifics, like what's going to be in each one. So each with, we have 6, what was the 18 representing? Oranges. Okay, 9, what was this representing? 27 was talking about pears. And 4, 12 was talking about bananas. Okay, so 3 baskets, each of them with those different fruit inside. Okay, if you got that right, good job. That was a tough one. Okay, final one, last chance to do it on your own. Okay, again, pause it, try it yourself, and then unpause it and come back. All right, now that you unpaused it and you're back with us, let's see if you got it. It says, Lisa is making activity baskets to donate to charity. She has 12 coloring books, 28 markers, and 36 crayons. What is the greatest number of baskets she can make if each type of toy is equally distributed among the baskets? And how many of each supply will go into the basket? So again, they want to know how many of each one will go in. And it is, again, a GCF problem because what's the greatest number of baskets? And these are the 3 numbers we're dealing with. So we have 12, 28, and 36. What do you see that can go into all 3 of those numbers? 2 can. So then you would have a slightly longer ladder than me because I see that 4 can. 4 goes into 12 how many times? 3 times. 4 goes into 28, 7 times. And 4 goes into 36, 9 times. Can anything go into 3, 7, and 9? No. So there's my GCF. That's the greatest number of baskets that we can make. And again, they want the specifics. So each basket has, we said 3, 12 was talking about coloring books. And 7, 28 was talking about markers. And 9, 36 was talking about crayons. All right, and that's it. If you got all those right, congratulations, my little mathematicians. You've conquered GCF word problems.